Okay, so now we are on to lesson 2. And in lesson 2, it says that we are going to be writing the equilibrium law and then calculating the equilibrium constant. Okay. Now, in order to do both of those things, we need an ICE table. Okay. Basically, ICE tables are going to set up all of our problems. So it says here that nitrogen monoxide gas reacts with oxygen to produce nitrogen dioxide gas. So it hasn't given me an equation here, but I can write one, okay? So it says nitrogen monoxide, okay? Nitrogen monoxide is NO. So NO gas is reacting with O2 gas, and it's an equilibrium reaction, so I'm going to use both arrows to produce nitrogen dioxide gas, okay? So all I'm going to do here is balance this, okay? Clearly, this is an unbalanced equation. So if I put a 2 here, I'm going to get 4 oxygens. If I put in 2 nitrogens, so I can put a 2 there. My equation is balanced, okay? Now what I need to do is I need to set up an ICE table, okay? So I, C, E, right? And I'm just going to put up here that they are all in moles per liter, just so I don't have to write them, okay? Or write the units every single time. Okay, perfect. So my black marker is dying, so I'm not going to do the lines, but you guys can do that. So it says here that the initial concentration of nitrogen monoxide is 0.043. 0.043. And it says that the initial concentration of oxygen is 0.066 moles per liter, but I have it there, so I don't have to write it. And the initial concentration of nitrogen dioxide, 0.068 moles per liter. Okay. It also tells us that at equilibrium, so that's down here, the concentration of nitrogen monoxide is 0.017. Okay. Calculate, write the equilibrium law, calculate the expression. Okay. Let's just start with the ICE table. Okay. So if I look at this ICE table, all right, I need to figure out what the equilibrium concentration is for oxygen and for nitrogen dioxide, so I can write my equilibrium law and find my equilibrium constant, okay? Where am I going to look to do that? Again, I have to look at the most complete column, which in this case is nitrogen monoxide. Nitrogen monoxide starts with 0.043 and changes to 0.017. So has it gone up or gone down? It's gone down. So I'm going to put minus, coefficient is 2, 2x. Okay. Now, if that reactant, it's on the left side of the arrow, if on the left side of the arrow, this is going down, that guarantees that oxygen, which is also on the left side, is going to go down. But I'm only going to put minus x because the coefficient is 1. Therefore, if the left side is going down, the right side is going up, coefficient of 2, 2x. Okay? So what I need to do now is I need to solve for x. And again, we are going to look at the most complete column, which is nitrogen monoxide. I'm going to write my information out in an equation. So I'm going to say 0.043. Okay. Again, you can leave out moles per liter here if you want. I like to write it moles per liter minus 2x equals 0.017 moles per liter. Okay, again, we want x to be positive by itself. Switch these around. 0.043 moles per liter minus 0.017 moles per liter is equal to 2x. 0.043 minus 0.017 is 0.026 moles per liter. But that is equal to 2x. So what do I need to do to both sides? Divide by 2. And you're going to get that x is equal to 0.013 moles per liter. Okay. I can now use this information to figure out what the equilibrium concentration is for oxygen and what the equilibrium concentration is for nitrogen dioxide. All I have to do is now sub X into these and work my way down. So if I look at oxygen, oxygen is going to be 0.066 minus 0.013. That's going to give me 0.053 moles per liter. If I go onto the other side, nitrogen dioxide, which is going up, I'm going to do 0.068 plus 2 times 0.013, which will give me 0.094 moles per liter. Okay, so we've done our ice table. Now what we need to do is write out our equilibrium law, okay? Just so I have more room, I'm going to erase this, okay? But you guys obviously should not, okay? So we have our equilibrium concentrations. Now what I need to do is I need to write out my equilibrium law, okay? Now, my equilibrium law is an expression that shows the relationship between the products and reactants. So I'm going to write Kc is equal to, okay, the products, concentration of the products over the concentration of the reactants. Okay, simple enough, right? But now I need to say what are my products and what are my reactants. So my products are NO2. So I'm put the concentration of NO2 gas, because gases count. And because there's a coefficient of 2 here, I'm going to put a superscript 2, raise it to the power of 2. On the bottom, I've got nitrogen monoxide, which is a gas, which counts, raised to the power of 2, and oxygen raised to no power because the coefficient is 1. This, ladies and gentlemen, is your equilibrium law. So on an assignment, if I ask you for the equilibrium law, this is what I want, okay? So how then am I going to determine the equilibrium constant? All I'm going to do is take these numbers and sub them into my law, okay? So I'm going to keep those numbers. I'm going to erase this just because I am running out of room, okay? So to determine the equilibrium constant, which is Kc, it's going to sub everything in. So Kc is going to be equal to the concentration of NO2, 0.094, have to write the units, moles per liter squared, divided by concentration of NO, which is 0.017 moles per liter squared, times 0.053 moles per liter. Now, the equilibrium constant does not have units. I want you to write the units in the expression, but the final answer will not have units, even if they're not going to cancel out. It's a unitless value, okay? So what I would recommend doing, guys, to solve this problem, okay, is just go step by step, okay? So I would just write out, I would do 0.094 squared in my calculator, okay, the old-fashioned one. You get 8.836 times 10 to the negative 3. I would then divide that by 0.017 squared. Okay. That's going to give me 30.5743 ... And then I'm going to divide that number by 0.053. And it's going to give me 576.875 ... In terms of sig digs, we just use normal. Because there are 2 sig digs in these questions, okay, this is going to have 2 sig digs. So we're going to write 5.8 times 10 to the power of 2. That is what Kc is going to be equal to in this example. Okay, what does that mean? What we said, Okay, if I look back at my reaction, which was 2NO2 plus O2 reacts to produce 2NO2. When we said that Kc is greater than 1, or I guess you're going to get to that in your notes. When Kc is greater than 1, the products are favored. So what that means, guys, is that the reaction is favoring the production of the products, which makes sense if you look at your ICE table, because your ICE table has products going up and it has reactants going down.